Okay, for those on this live stream, this is another episode in our internal design reviews for the next version of Wolfram Language. This particular one is about displaying automatic proofs. And why don't we start by looking at an example here? So do I have to run this thing? Is that necessary to run that, or is that unnecessary at this point?
If you are using prototype build, that's unnecessary.
Okay, so let's just try to understand what's happening with this. Okay, so did we get any input from graphic design on these things, or has that not happened yet?
We discussed this morning with them, and we have been focusing mainly on the natural deduction diagrams.
I wonder if we can see whether Jeremy, again, see if he's available. Can somebody do that?
Yep, I will call him.
Thanks.
So basically, they only had comments on colors for the proof networks. Otherwise, they said they look okay.
All right. Well, let's try. Okay. So now you've defined this new proof object, correct?
Yes. Yeah. So the idea is that it will have as first argument the type of logic we are using, so that it's reusable in the future with other proofs coming from Lean, etc.
Okay. So how do I use this? So this.
Right now we don't have any more information, but we have methods to extract information like proof network, etc. So Jonathan knows better.
By the way, this is hardly beautiful. I mean, it may be beautiful in functionality, but it's hardly beautiful in graphic design. Now, what's your really funky, this human readable thing? Which, by the way, I think is a really weird name, but okay. So what is this, and how is it formatted?
So this is producing a notebook document programmatically, and it's just taking every proof step. So every node that's in the proof network displayed above, and it's providing just for each expression that appears in each proof step, it's providing a natural language description of what the significance of that expression is. So for the substitution lemma, it's saying, we prove this lemma by taking this object, hypothesis 1. We apply this substitution, which is justified by axiom 1.
Yeah, I get it. Okay, but so the fact that it says substitution lemma camel cased is a little weird here, right?
Yeah. I mean, we can have that spaced. Yeah.
Okay, so the next thing is we need somebody who knows about notebook design, which means probably Andre or somebody in that group.
Jeremy's here as well.
Okay, can we see if we could find Andre, if Andre is available just for a couple of minutes here?
Will do.
Okay, hey Jeremy, we are looking at these proof diagrams and so on. So first of all, this thing here with its brown and blue is coming from some kind of layered graph plot thing, right? Is that true, Jonathan? So there's a new version of layered graph plot, isn't there? That's
the version of the function we're using. I think we're using layered graph plot new in a.
Your audio is breaking up.
Yes, so he was saying that we are using the new version for the proof network itself.
I don't. Oh, for the proof network, but what about for this thing here?
I think that's still the old one.
Okay, so that needs to be fixed because its colors are really yucky. Logic, equational logic. Are we calling it equational? What are some other examples of logics?
Well, in the future, we will have things like first order logic or higher order logic or intuitionistic logic, this sort of thing.
Okay, but do we want to okay, but do we want the name of the logic to be equational logic, or do we want the name of the logic to be equational?
Oh, I don't know.
Okay, I'm back.
Okay. Hey, Andre, we are looking at this. This is automated theorem proving stuff, and that's an automatic notebook generator, and the styles of this notebook leave something to be desired.
Yeah, it looks to me like, can you unformat one of those cells, like just even the text cell? That one's fine. It wasn't wrong to begin with, but show me the text cell there. There's
Yeah, it
no
doesn't have a style.
so that would be why. How is this being generated?
Jonathan, is there a template that you're using? Some kind of
There's just.
All right. Well, obviously he could be
No.
connecting with us, and we can help him out here. So I think I'll just make sure we follow up with him on this. Is that right?
Well, yeah. Jonathan, are you there?
Mm-hmm. Yep.
Yeah. Can you explain? Is there a notebook template that this comes from?
No. It's right now. It's just a bunch of cells that are being generated programmatically. But yeah.
Okay, but what's the right way to get this designed? And because just putting in the style, we may need a particular style, right?
Yeah, I mean, if you want it to look better than it is now, you could just use the default style sheet styles. But it does seem like maybe it needs something more than that. If there's
the only problem is that if it isn't default style sheet, let's just think it through for 1 second, okay? This thing, can we make a more complicated one of these, Jonathan?
Yeah, there should be plenty of examples in the documentation. If you scroll down a bit more, there'll be. I mean, that's a reasonably complicated one there.
This one here.
Yeah, the properties and the axioms are in 2 parts.
That was fast. That was very fast. Okay. So it goes for a while. It's nice and fast, at least.
But Stephen, the theory is that these would always be put in this kind of framing device you have on the page. Is that right?
Well, that's a notebook. That's just a notebook object, isn't it? That's just displaying a notebook object, correct?
Yep.
An embedded notebook object.
Yeah.
So
I mean, then many people will click that. Has anybody tried this in the cloud? Does it work in the cloud?
We haven't tried yet.
So those the code that is there, do you expect that to just be input, or do you expect it to be some other form of code format?
Jonathan?
That can be, in a sense, it doesn't really matter whether it's input or whether it's not.
Well, but it might as well be input, because that way people can copy paste it.
Yeah. I mean, I guess it makes most sense if it is.
So I mean, just naively, this would become a text cell. I guess I can just do that.
Well, actually, probably code text, right? This is not much different than a computational essay, really. Is it?
No, it isn't different. So that would be a good code text cell. But now, how do I get that to code text? Style.
Well, were we giving you a shortcut for that?
Yes, but that was based on DocuTools being up. Let me get DocuTools up, even though DocuTools wasn't working here.
And we're having trouble reproducing that problem, so that I have to understand why it's a problem for you and not anyone else.
Okay, well, that would be a Roger issue. I mean, somebody suggested that was because it had set some notebook to null.
Well,
okay, but
overcomplicated suggestion. I was worried it was something to do with sharing, but we'll see.
Yeah. Okay, but now this cell, I don't understand why this is a small. I don't even understand what format this is.
We'll just put comma code text and return that. There you go.
Okay. Okay, so then this would be
input, right? I mean, these could all have been created that way.
Yes. I mean, it might be faster for Jonathan to edit his. Okay, well, so one thing that's going to happen if they're all input is there's going to be a lot of blue on this page, which is probably okay.
Well, and that's part of why I was asking, like, does that matter to you guys or not? And
no, I think this is perfectly nice. I think it's certainly nicer than what it had before there. Now, what is that cell? That's a subsection cell. Possibly it shouldn't be a subsection cell. Possibly it should be a subsection, like that. Now, okay, so what you have here is something, wait a minute, proof. So proof is a sub case of this, right? So this is critical pair lemma 1, and then it has a proof, right?
Yep.
So naively, if that was a 6, and that was proof, and maybe proof got italicized, maybe it doesn't get italicized. I don't think the italics are helping there.
In our publishing-based style sheets, of which we still have a few, we do have style definitions for proofs and lemmas and all those kinds of things. But they're in the context of, journal publication, and I'm not sure that's what we want to apply here.
No.
And also, where you have an input and don't have an output, it kind of affects the margins a bit. Outputs have more margins below them than inputs do. So there's a bit of fussiness here if you're not going to evaluate any of this stuff.
It doesn't make any sense to evaluate it, I think, unless these are output cells, but I don't think, what makes more sense there?
Well, if instead of input, they could be code, right? We have a few other styles to consider.
Well, let's go here. That's a 7 there. Yeah, you see, look, that's not going to work because this code text style is set up to be
a one-shot caption, not a continuation of text.
Right. I mean, this doesn't look terrible. It looks better than it did before.
Well, all right. So then maybe don't use the code text and just make that command 7. There you go.
Okay.
And so all you're really saying is, for what they're generating, throw text and input in there for now, and it's easier.
Well, and subsection, and this becomes a what is that cell? That is a subsection cell.
Right, and you want proof as subsection. Yeah.
So are these the only elements, Jonathan?
Yeah. You, at most, you're going to have a subsection like critical pair lemma, and then a proof, and then there's no other sort of hierarchy to it.
Okay, and we think. Okay, are you able to just in real time modify this code and just try seeing what one of these notebook objects looks like in with this? By the way, sub pattern. Obviously, if we're going to use something, we should add it to the spell checker. Hey, Sushma,
Yep.
could you do that?
Yes, doing it.
Since we don't want every single proof that comes out to have spelling mistakes in it, or to have apparent spelling mistakes in it.
I can try and modify some things.
No, it's okay. We'll modify the spell checker so it won't pick up sub pattern as a spelling error.
Oh no, sorry, I meant modify the output for.
Right. So question, guys, if we were to put a background color on some of these things, which would not hurt anything, do you think that would make this look? So remember, this is what it's going to look like. The other possibility is that we could close up the proof there by default. In this
like that. I like
human readable thing.
Yeah. It might also want to have the opener, the group opener icon.
But we're getting group openers by default in 11.3.
Okay.
For this case. Jonathan, I know you're paying attention to something different, but what do you think about the idea of closing the proofs up by default?
That sounds good. Yeah, no, because that will fit with our sort of format for displaying the proof steps more sort of better than it does at the moment. Because by default, if you request a list of proof steps, it will only show the sort of high-level lemmas and things, and you can request to drill down and see the proof. So yeah, I guess for consistency, it would make sense to have that.
Okay. And what does it say at the end of the whole thing? Does it say QED? No, it just says we obtained the conclusion true. Magnificent. Okay.
You could say, there you go.
Something like that.
Right.
Well, all right. So can you let me go?
Yep. See you later. Okay, Thanks, right. Andre.
Yep. All right.
Bye. Jonathan, are you going to be able to modify this in real time or not?
I'm going to see what I can do, but
okay. Okay. So, by the way, I hope you have my nice Boolean algebra thing in here as an example.
Yep. In fact, I think
I've seen that one multiple times, so therefore I know what it looks like.
Yeah. Wait, I'm trying to work out the thing you just proved. That was a different Boolean algebra thing, but that's also some axiom system for NAND. But it's not the one that you ones. I think all of the ones that use the single NAND axiom, all of those proofs are too long, I felt, to be reasonably generated. But I can add them to the document.
Yeah, you should absolutely have them in the application section here.
Sure, yeah.
Okay. So let's go through the question. So for Jeremy, there's the question of what these things look like, right? So we've got, this is ridiculously long. Actually, we've got two things. We've got the data set and we've got, what is that? That's the proof network, right? So this there, %9 proof network. Well, that doesn't look so bad, actually.
Yeah, we looked at this morning for a bit. We're going to update the colors, and there was some default labeling, which actually looked okay.
Don't you think the dashes are really coarse here? I think they would look better as finer dashes.
Do they, right, dashed versus solid, they mean something in this system?
Yes.
Really, okay. Yeah, it's something finer grain.
Could be different color. I mean, what do the dashed lines mean?
So the dash, so the solid lines show where a construct is being used as an input to some rule, and the dashed lines show where a construct is being used as the justification for a rule.
Okay. What do you mean input? Well, okay. So did you come up with a different color palette that actually means something? Because I don't know what on earth these colors mean. You know what? We could consider having a proof network captioned property here.
Mm-hmm.
Captioned or labeled, legended. Well, captioned is okay. In which there is an actual caption that explains what these things are. Does that make sense?
So it's a legend of explaining the types, color types.
Yes.
Okay. Because there's a labeled version of this, which has
there is?
labels. Yeah.
What?
Well, there is a threshold. If there are less than 10 nodes, then they get labeled.
We should have a way. How do you get it labeled if it has more than 10 nodes?
There isn't a way at the moment, but we can add some kind of override.
Why don't we say proof network labeled is the labeled version? Because somebody might want to make a whole wall chart out of this.
That's fair enough. But our reason for excluding it was that the labels. Because
no, you're right. The default is correct. You're right, what you're doing by default. No problem with that.
Right now, there are tooltips.
Yeah, I see that. But I think proof network and proof network labeled. So these are all properties of the proof object, right?
Yeah.
So, okay. So is proof network a graph? Is that thing there a graph?
Yes.
No, that's a graphic.
Oh, sorry. Yeah, it's a graph that's being put into layered graph plot new.
But does layered graph plot actually produce a graph or not?
It may produce a graphics. I don't know.
Can we find that out? Can somebody see if they can reach Charles Poo? See if he can join us.
Okay.
I'm calling him now.
Okay.
Well, the fact that the predictive interface is showing frame, labels, etc., probably points in the direction.
Yeah, it's probably a graphic.
It's a graphics.
Right.
Yeah.
So the question is, we also need something where this is an actual graph.
Right.
Am I making sense? Because somebody won't want to manipulate it as a graph.
Mm-hmm.
Right.
So that's another.
Should proof network by default display a graphic or?
I don't know.
Return a network.
I don't know. It would be much better if those two things were equivalent. If you understand what I mean. In other words, if there was a way of specifying in the graph that the layout should be a layered graph plot, right? So that the whole thing can then be an actual graph that can be manipulated.
Mm-hmm.
Right.
Okay. Let me see some other cases. So. First of all, what are the horrifying? Okay, so again, let's talk about this picture. Let's look at a simpler one first. Okay, so this is a simpler one with labels. The labels are really kind of ugly, And the fact that those dots get bigger is really pretty horrifying. Do we know how to fix that? Do you know what that is? How are those dots specified? So you understand my problem, that if I resize this thing, those dots are getting super big. Also, this font, where is this font coming from? Is that a default text font or what?
That's a default for vertex labels, vertex labeling automatic. So whatever the default one is.
The default sans, which Helvetica Arial.
Okay. Why does this look so incredibly ugly, Jeremy?
It's too big for the data. Right? It doesn't need to be that big. I don't know how you scale the dots, but it's actually not changing size, which is the problem, right? It's not getting smaller as you scale.
Right. Okay. So that may be the issue, that we may need to have some default, and that may be an issue for layered graph plot, because layered graph plot was supposed to be something. I mean, graphs in general are supposed to lay out at a size that depends on how much data is in them. Okay. So I think this is an issue there, and that would be fixed if this didn't. So let's take a look at a slightly larger one. Where's a slightly larger one?
I think in applications, there are some group theory proofs that are a little bit longer.
What happened to your inventory
of
all known axiom, equational axiom systems? Do you have that someplace?
No, because we had this equational theory function which would return axiom systems, but we decided in the ILD meeting we discussed whether it would be better to have an association, and then I think on Saturday you suggested having the axiom systems as resource objects.
Yeah, my suggestion was just put a single, for now, just have a single data repository entry that has the known axiom systems in it.
Yeah, right. So there would be one resource object for all equational axiom systems that we have.
That's what I think we should do for now. I mean, eventually, with luck, there'll be so many of these things that we'll want to break them apart into their own repository.
My concern with that is how do we actually represent them? How do we represent the resource object in such a way that we can parameterize the axiom systems you get out? So you have a user requests an axiom system for abelian group theory or something, and we don't want the user to have to use the default multiplication operator or something, which the default might be G, but maybe the user wants to use mult. How do we allow that? We can't just have like an association, I think.
Okay, so let's understand that. So Jeremy, by the way, the fact, it would be really good if Charles was found.
I'm here.
Oh, okay. All right, well, question for you, and then let's go back to this resource data thing. Okay, so we're using layered graph plot here, or some kind of layered graph layout. Is there a way of getting graph to lay itself out as a layered graph?
Yes, you just have to specify the graph layout option.
So wait a minute. So wait a minute. So then you will get the same looking layout as this is an 11.3 prototype builds here. So what do you do? Hey, Jonathan, how do I get the actual graph out here?
I don't think there is a way at the moment.
Okay, but so give me an example. So let's say I do a Carey tree 3-2 or something. That's a boring one. How do I do an interesting Carey tree? 5. How do I get something which is where I can actually see that it's layering the graph plot? Let's say 4-2. Oh no, what am I doing here? What do I need here? 8-2? No. Charles, what should I do here where I can tell the difference?
Well, the thing is that, for small size, about 1,000 vertices, we kind of detect that and pick the right layout. So that's why that's happening. Especially for Carey tree, we kind of know that.
Okay, actually, fine. Okay, so look, the issue we have is this thing here, which has been done with a layered graph plot.
Yes.
But we want this to be an actual graph. Jonathan, can you just extract from your code right now the graph that turns into this? Did we lose Jonathan? Hello. If we lost Jonathan, can we ask him?
Sorry, I missed that. What was it?
If this Zoom thing isn't working, I suggest you call on our phone to the Zoom connection.
No, I think he was just muted.
Okay. Can you give us a graph here rather than the plot, the actual graph, so we can try what Charles just said about using graph layout?
Sure. Do you want me to send that to someone, or?
Yeah, you can just send it to me.
Yep, I'll see if I can do that. Hang on.
Okay, so Charles's claim is that if I just take this, let's just take Charles, how do I actually see this in some reasonable way? Let's take a random graph. Let's say 20 nodes. That's really boring. Okay, how do I do this as a layered graph plot? So I would say.
So you say comma graph layout goes to layered graph embedding.
Layered graph embedding. By the way, why isn't that in the autocomplete? That seems to be a bug. Sushma, can you
Yep.
can you get that? Layered graph embedding.
Yes.
Is that new?
Oh, so is right. So we detect that is not actually a layered graph, so we don't do that.
Shouldn't it give a message in that case, Charles?
Yes, but since it's more auto visualization, we kind of reduce the amount of message, but we should add that, I think.
Okay. How do I get a layered graph, please?
So if you just go to graph layout documentation, we have example inside. And under well, everything is open. So if you go to scope under vertex layout section, there is like the example about
why is everything open here? That's a bug in this is 11.3. Okay, where do I want to go? Layered.
Yep.
Layered embedding.
Yes. So there's layered embedding and layered graph embedding when it's a directed graph.
Well, this is a directed graph, right, Jonathan?
Yes.
Yep, it's directed. Sorry.
Okay. Did you manage to extract the graph for us to try?
Yeah. How would I go about sending it over?
Just send email. Just what do you mean? Take the graph.
Oh, sure.
And copy it and send email. Or alternatively, we can look at your screen, but I think it's easier if you just send it by email. We could be very high tech and we could use the chat system, but it probably won't work for right now. Okay. So again, can you make sure, by the way, also, Charles, that these autocompletes for the thing you just said, also the layered, whatever it was, the directed graph thing, that also gets correctly and inserted into the autocomplete?
Yes, I will talk to. Oh yeah, I will fix that. I will discuss that today.
Okay. Okay. So while we're waiting, Jonathan, did you get this email sent? Okay. We also need to look at that other representation of the proof that was. What is this? This is what is this thing here? This mock-up that was sent. What is that?
Yes. So this morning we were discussing natural deduction diagrams with Jeremy, and rather than having a line separating the premises from the conclusion, we thought that these two colors.
What is natural deduction? I'm sorry. Is that like old-fashioned Frege stuff?
It's called Jensen style, and it's this idea of having lines separating the.
I think that came from the Bergrefschrifty thing of Frege's, modified by Gensen, I would suspect.
I see.
Okay, so
we also have support for Hilbert style things as well, but yes, that's a piano style proof.
Explain, because I don't know. And then what does the Hilbert style proof look like?
This is the new design for.
Jonathan, your email was empty. Just take the notebook, take a thing in a notebook and attach it. Oh, maybe this one isn't empty. Now we have one that isn't empty.
That has the input form.
Yes. Okay, fine. Okay, so here we go. So this is, what is all this junk? So actually this is relevant for Charles to see. This is the thing, okay? So that's that graph, right? With a bunch of directed edges.
Yes.
Okay. So now Charles's claim is, so let's just see what this looks like. Did it automatically detect that it was layered?
Yes.
Well, so what's the problem, Jonathan? The problem is solved.
Yes, I mean, when I was developing the layered graph thing, I was using an older Ectkernel build, and the graph laid out very differently to that. So this may just be.
The only issue you may have is the detection of the root vertex, right? In some cases, we don't understand the graph. We just structurally look at the graph, and then we.
Can you hint it with the root vertex?
Yes, there is an option where you can say root vertex, and then you specify the actual root.
Okay, so Jonathan, that's what you need to do.
Mm-hmm. Yeah.
Did that make sense?
Yeah, we just take the most densely connected axiom or something and specify that's the root.
Is that what you want to do? As opposed to take all the axioms and specify them as the root?
Can we do that?
Charles?
No, no. The thing essentially is that we analyze the graph and try to find the root. There may be, we may find that there are two roots, so we pick one by default. So the point is, do you know if your graph have a main root or several of them? That's kind of the issue. If your graph, like in this case, right, you have actually two on the top there.
Yes.
So the problem could be that the root is actually the end node. It's just that the graph is kind of reversed.
Right. Then you will see the arrow goes up, right, instead of, yeah.
Wait a second. Okay, but okay. Just to get this picture, what you're saying is that Jonathan should put in here, graph layout goes to something or other. How about Sushma sends mail to Charles and Jonathan to connect them, and how about Charles tells Jonathan what option to put in here?
Yep, you can do that. Mm-hmm.
But otherwise, this looks like it's working beautifully. Great. Does this automatically lose labels, or did you tell it to lose labels, Jonathan?
I told it to lose labels.
Would it automatically lose them, Charles?
No, by default, remember we changed automatic, so if there are labels, we always display labels.
So, and do we think this is, so vertex style, so these are the names of the vertices, like substitution lemma 3, right?
Mm-hmm.
And these are the color palette which Jeremy is specifying a better one of, or something.
Yep.
And this dashing small, I mean, I would like to suggest that we try, instead of dashing small, why don't we try dotted? Isn't there a thing called dotted? I haven't used this in forever. Let's try it. Oh, come on. That's really weird.
Oh, right, because graph is a raw object, so replace doesn't go inside after you build it.
Growl. Well, there is another solution here, which is really grotesque. How do we even do this? And copy dashing small. How do I get the innards of the thing without how would I get the innards of that graph object? There we go. Doesn't that look better? If I might, don't you think that looks better?
Looks good to me.
It looks pretty light, at least through my session. Like they could be tighter. The dots are good. I just feel like they're loose.
You mean the dots could be closer together?
Yeah.
Well, that may be an issue with how dotted works in general, which is a question for Brett. We could also, okay, but anyway, I think it looks better to have something less coarse, so that should be spec'd somehow. I agree that they look kind of silly relative to the arrows at the end. Again, explain, Jonathan, one more time. These are things where, why isn't there a sequence where the substitutions are just being followed down in solid lines? Why are there a bunch of things where there are only dotted lines?
Well, so for the critical pair lemmas, there are only dotted lines. Because if you have some equation like A equals B, that equation can be used in two ways. You can either take that equation and apply some rule to it, or you can take the equation and convert it into a rule so that A goes to B or B goes to A. And so the dotted lines are showing where you're converting an equation to a rule, and the solid lines are where you're taking an equation and applying a rule to it and deducing some other equation. So with the critical pair lemmas, which are the orange ones, you only have rule, because a critical pair lemma is there's no substitution. It's an entirely rule-based thing. And then with the substitution lemmas, which are the yellow ones, there you have an input and a rule.
What is green?
Green is the hypothesis. So we're taking out red is an axiom.
Okay,
yeah.
So listen, guys, come on. These have got to. Is there any chance of us? Okay, so the point is, these things here go with the dotted lines, basically.
Mm-hmm.
Right. So what would make more sense, it seems to me, would be to color those dotted lines something which sort of resonates with the color used for the critical pairs.
Sure.
Why yellow is the color associated? I mean, why isn't that a bluish color that goes with, or whatever color goes with the color of the things that actually represent those substitutions? Mm-hmm. You see what I'm saying?
Yep.
And then in terms of it's kind of weird that the axiom is red, stop, and the hypothesis is green, go. That seems just weird to me.
Mm-hmm.
Now, is there any possibility, this is, I guess, a question for Charles, is there any possibility of any iconography other than a circle here that won't mess up?
Yes, we can put anything there as long as we adjust it correctly, yes.
Well, but what would you suggest? I mean, like, do we have standard symbols for graph elements?
No, except the circle.
Is there anything other than a circle that's standard?
A square, but beside that, they are usually circle or square.
But I mean, you're just stating, but do the arrows correctly hit a shape of a different shape, so to speak?
Yes.
That's clever.
As long as the shape is roughly, we can approximate it to a polynomial. Yeah, most of the cases.
So long as it's approximated by a polynomial?
So what I mean is that here is a circle, so we can actually compute the distance. If you put an image, we may make a mistake, right?
Okay, but so for what will we not make a mistake?
Anything which is a graphic. They just say that. So graphic built from B-spline, B-spline, or a graphic primitive.
Interesting. Okay. So do we have a thought there for what these should be then? So what would naturally, I mean, to me, these things would be naturally some kind of arrow down, like they're being introduced. I don't know, or some start. Is there some symbol in, I mean, look, for example, this is almost like it's the square for the QED at the end.
Yeah, I think the standard would be to use a kind of tombstone square for the conclusion, and I may be wrong, but I think the standard is a sort of diamond for axioms. But I can check that. There definitely are sort of conventions on proof networks in terms of the shapes of the nodes.
Really? Okay. Well, then what's the shape of the node for a critical pair?
That probably doesn't exist. I mean, because critical pairs tend not to be a feature of human proofs. They're really a sort of only a kind of thing that appears.
So you're saying if we look for a proof, a typeset proof, you think that there will be decoration. You think that I mean, certainly the QED is decorated with a quad or something, printer's quad thingy, and you're saying, I don't think I have a proof readily at hand here. Let me see. You're saying that there's some decoration that will be, let's see, if I say proof and I go to images, oh my gosh, you do not get the type of proof that we think. Here we go. Here are some images. It's kind of amusing. Okay, so here, that is like Russell and Whitehead, isn't it? Something.
Yep.
That weird thing there, what is that weird thing there? That weird thing there is a...
That's a semantic implication, I think.
Okay. Let's see. That's not really proof writing. Okay. Oh, that's one of those Begriffsschrifty thingies, isn't it? I mean, that's one of those
Yep.
the thing you're calling a natural deduction proof.
Right.
Okay, that's not really the same thing. That's not the same thing. Oh, I noticed that they're using proof with that is a pretty common thing to use proof with small caps like that. I wonder if we should do that too. In the printout type thing. That's not very useful. Oh, that's fun. Okay. My God, that's another thing of mine. Okay. That's a bad sign when you look up something thinking you're going to find all kinds of stuff in the outside world and you find stuff that you wrote yourself. That is a bad sign for the general interest of and that has to be one of ours too. Yeah. Who knows? Okay. That's different. All right. Okay, so look, it sounds like a little bit of work should be done trying to figure out what these icons should be. Let's talk about, okay, so is that everything we needed from Charles? Anything else from Charles about graphs? So the end result of this is that proof network, should we call it proof network or proof graph?
Proof, if it's returning a graph object, then proof graph seems like the natural choice.
Fine. Why are we calling it proof graph rather than just graph? Given that it is in a proof object, let's take a look at what we've got here. I mean, we could just call it, well, Look, you can't call some of them proof and some of them not proof, right? You can't call it human readable. I would call that notebook. Why don't we call it graph? Okay, so here's a possibility. We could call it, we could call this one validation function, if that's what it is.
Well, we initially called it verification, but there were various reasons for renaming it proof function, namely the fact that it's only actually verifying the substitution lemmas and the rule applications. There are aspects of the proofs of that function will not verify, particularly.
Okay. All right, fine. So look, maybe what we should call it is proof steps, proof network, proof notebook.
Mm-hmm.
Proof written out in a notebook. Does that make sense?
Yep.
Now, you said you've got some other things, which are these natural deduction things, right?
Yes, they're not documented because they will be broken in the version that you are currently using because we restructured the proof objects. Okay.
What is proof steps? Is proof steps really a list of proof steps, or is it something different?
It's a data set, which I should rewrite that.
Well, then why don't we say, there is a certain argument that we should just name this one graph. What do you think, guys? If we called that graph, data set.
So this may not be a good argument, but my justification for using the proof prefix was that we have these accesses like theorem and axioms, and we also have logic and things. They're not features of the proof itself.
Yeah, you're
They're
right.
kind of metadata features of the.
All right, fine, I'm sold. So let's say, are we going to call it proof graph or proof network? Proof graph is probably fine.
Yep.
Okay, so proof data set, proof steps as a data set. Is there any other form that we want not as a data set, like as an actual list?
It's pretty much unreadable as a list. I mean, we originally did format it that way, but I think the feeling in the ILD meeting was that data set was more natural. We could offer both if you think, but.
Well, I don't know. If there's some programmatic reason why the list is more useful, that might be worth having.
Sure, but I mean, I think your justification was that the list is sort of trivially extractable from the data set anyway.
Okay. Okay. What would happen if you took a proof object and just said graph of this proof object? Can we make that work? Or data set of that proof object?
That would be nice if it worked.
I think it can be working through up values, if you know how to set those up.
Yeah, we can do that.
Okay. So then we need to make sure that we document that. Etc. Okay. Okay. All right. Can we loop back? Do you want to show? Okay. Was there anything else for? I'm sorry. Was there anything else for Charles here about this graph? No.
No, I think so.
Okay. Unless, wait a minute, the collision of these labels, is there anything, Charles, do you have any thoughts about that? Is there anything we can do there? Or is that just hopeless?
Well, we are actually working on a general labeling algorithm to avoid the collision. So unless you actually know yourself, the length, then you can specify it. So.
Well, we do know the length. I mean, we don't know the font rendering. Right.
Right. Yes.
Okay. Oh, I think you're in the trees meeting, aren't you, Charles? Which is going to be a few minutes late. So.
Yes.
Okay. See you there.
See you.
Bye.
Bye.
Okay. So can we look at this natural deduction thing for a minute, and then I want to talk about this resource object thing.
Sure.
Should we look at your screen for the natural deduction thing?
Yep, I can show that. Hang on.
Okay. Meanwhile, let's talk for a second about the, okay, let's go ahead. Okay.
Yep, sorry about this.
Did you manage to make that work? Wait a minute, that was the redone.
I was halfway through it. It's not complete, but yeah, I was.
Okay, good.
Yeah, okay, let's take this. And actually, no, let me start with a simple example. So what are we doing? So I think we experimented with a few different formats. Like the original one I think we did was this, and then there's a more verbose version that's not, in my view, not as nice. But I think
well, whatever is true, it shouldn't be textual. We might as well use graphical elements in these things.
Yes, yeah, I agree. And so I think the one that we decided on was the natural deduction concise, and this is the object that corresponds to the mock-up that I think Jeremy sent you. So the idea is that so for each intermediate proof step, what we have is we'd have 2 or 3 boxes saying what's going into this proof step, and then we'd have a line, and then a box saying what's coming out of the proof step.
Okay. Well, it seems reasonable. And does that work when things get long? Does it go crazy or not?
I mean, everything goes a little bit crazy, but okay, let me take a slightly longer one. Of the various formats we experimented with, we thought this was the most read. I mean, this is hard to read because we don't have very good spacing between these proof steps. But if we use the format that Jeremy sent over and we space these out a bit more, I think this is probably the most readable we can make it.
So Jeremy's mockup has boxes. So it has 3 things on the top floor of each one of these.
Yes. So it has 3 things because in that particular case there was that was the proof of a critical pair lemma, which happens to take 3 inputs and evaluate to one thing. For a substitution lemma, it only takes 2 inputs.
Okay, so what does it look like in that case? Then it just has 2 separators. I mean, it has just 1 separator in that case?
Yeah, I guess so.
Why is that thing with a colon? I mean, why have the thing... See, the thing that doesn't make a lot of sense to me is the output. You're having a colon in the output, which is just, why not make it graphical? The fact that there's a colon there, make that more graphical.
I agree. So, I mean, I was wondering if it might even make sense, given that, so we're saying take axiom 2, axiom 1, and it evaluates to A equals C, but then maybe we just title this thing as substitution lemma 1. Does that make any sense?
You tell me. I don't. It makes sense to me. I just don't know how bizarre that will be to people who are into these kinds of natural deduction proof things.
No, I mean, as a natural deduction format, I think that's perfectly fine.
Okay, so Jeremy, is Jeremy still with us?
Yeah, I am. Yeah.
Do you want to bring your thing up on the screen? Do you want to bring up Jeremy's email on the screen? No, I can do it.
Sorry.
I'll do it. Okay. So here, so the issue is we don't really need, okay, the main event is we are producing that critical pair lemma 2. We are doing that by feeding in this, this, and this. Right, Jeremy?
Right. Yeah.
So the only thing is, if we can label the thing, if maybe this is just simply a colored background down here, although I don't know how that's going to work, because it's like this and this and this goes to this, which is this.
Wait, is the output labeled as critical pair lemma, or is the whole thing labeled?
No, the output is labeled. Isn't that correct? The output, this is the proof of critical pair lemma 2.
Correct.
This thing here is the proof of critical pair lemma 2, which means this output is critical pair lemma 2, and what goes into that is axiom 2, axiom 1, and this.
Yeah, it still feels like it could go above then in that case, right?
It can, yes, it can go above.
Okay.
I like the idea of it.
Do you think you can come up with a format, Jeremy, for it to go above then?
Yeah, I think so. I don't even think it needs to be in the box. As long as it's above and typeset right, I think we can keep what we have.
Fine.
Yeah,
Okay.
I can mock something really quick here.
And do we actually think that it's better to have the conclusion be on a gray background rather than the things going into the conclusion be on a gray background? In other words, what's the most emphasized thing here?
Mm-hmm.
The conclusion, I would say.
Yeah,
right,
me too.
But that should be the most emphasized. But the fact that it's on a gray background might make it seem less emphasized.
I see it more. I mean, that's why I did that. It just pops a little more when you read down the page.
Yeah, because the background is white.
Fine. Okay.
Yeah.
Okay. Did you say you had some Hilbert-based proof thingy?
Well, I mean, sorry.
So, by the way, this is this would just be of a proof object. This would be natural deduction, quotes natural deduction form. Is that right?
Yeah, I think so.
Okay. And then you said there was some other form, this Hilbert form also?
Well, these more verbose forms that I was showing you earlier, these are closer to what I think is known as being like a Hilbert-style natural deduction.
What more verbose forms? You mean the ones in the notebook?
Yes.
Okay.
But
well,
I feel like even with appropriate typesetting, I don't think those are going to be particularly informative.
Right. Okay. Let's talk about your collection of axiom systems and so on. Okay. So your point is that each axiom system comes with certain operators and so on, right?
Mm-hmm. Yep.
And so the question is, what you would really like to be able to do is to have something where for a given axiom system, you feed it some association that tells it, it gives you an association that has that tells you what the parameters, like the names of the operators are, and so on, and then you give it some other names of operators or something.
Right. Yeah. I mean, ideally, we'd have some kind of default list of operators, but that the user could override them if necessary.
Right. I mean, the yucky thing, of course, about these operators is that they wind up in the context. By the way, this is
Can't we have them be formal symbols? Or
we could, except formal symbols right now are incredibly ugly, although we would like to change that. I mean, they'll be dotted all over the place with formal symbols. But yes,
I think we're going to have to use formal symbols, not for the operators, but for the quantified variables, because otherwise we're going to end up with loads of symbols just produced in global context.
Fair enough. Okay, but then, okay, so now the question is, in what form? I mean, so my proposal was that that basically we just have a single resource, and we just say resource data collection of axiom systems, or whatever it's called.
Mm-hmm.
And then it just says then they're, Robinson arithmetic or something.
Right. So the resource object itself would be an association.
That's the idea. The content of the resource object will be an association that just says Robinson arithmetic arrow that.
Right. Yeah.
Now, is it the case? I mean, each one is just an axiom system, right? For all type axiom system.
Yeah, it'll either be a single sort of quantified axiom, or it'll be a list of axioms.
Right. I mean, in each one, we are also going to want a collection of notable theorems for each axiom system.
Mm-hmm.
So ultimately, I mean, arguably, maybe this should be an association which contains the axiom system. It's going to be axioms, which are going to be a list of axioms, right?
Right.
And then, I mean, we're going to want other things like notable theorems, probably.
Sure. I like the idea of having axiom system metadata. My only concern is that I thought it's nice if we could just say sort of find equational proof and then have just put in resource data, collection of axiom systems, Robinson arithmetic as our axiom system.
Yes. Oh, let's look at Jeremy's mock-up here. That looks just fine to me.
Yeah, I like the way that worked out.
Any problem with that? Anybody?
No, it's fine.
Looks great to me.
Okay, can you? Was that just Photoshop, or is this code?
It's Photoshop. I was going to get a list object and try to typeset this though, so I think that's coming to me.
Okay,
Sure,
well,
yeah.
I bet Jonathan could do it too. Okay, okay. So look, the alternative would be how many axiom systems do we have right now?
I think the idea is to have all of the equational axiom systems that are on the 2 axiom pages of NKS, which I think comes to about 15, maybe
15.
less.
Okay, so I think there are a few others. I mean, do we think there are like another 10 or something out in the world?
Yeah, I've seen a few for sort of various areas of universal algebra that we might want to introduce. So yeah, but
what about things? What about things that have nothing to do with stuff like this, but are things like axiom systems representing protocols, representing pieces of Wolfram language, like the axiom system for join, append, prepend, those kinds of things?
If we can express them equationally, then they might be worth including. I don't know.
Yeah, I mean, some of those things, I think. Okay, so let's just understand our choices, because I agree with you that just being able to feed something into, well, if all we have initially, I mean, ultimately, we're going to want a thing that is called something like, what will be the, I mean, what we have, we have this thing called net model, which is for neural nets, okay? I mean, I wonder whether we could just have a thing called axiom system and then a name.
Yeah, I mean, we prototyped that with the equational theory and it worked quite well.
Really? Okay. Well, where is that?
That's not in the current build because it was decided in the ILD meeting, rather than having an equational theory, we should just have a single resource association. But I still have that code somewhere.
Why don't you get that code back out and let's look at it again? Okay. And
okay.
let's see whether is this the right way to call it? Axiom system data or something? So we might say axiom system data of Robinson arithmetic.
Is there any reason for the data being there? If we only wanted to return a list of axioms, shouldn't it just be axiom system? And then maybe there's axiom system data which has some metadata in it about notable theorems or whatever.
But Stephen, are you going in the direction of converting these into entities?
Oh yes, that is the direction we're going in. Yes.
Because then this could link to Michael's project of theorems in general, etc.
By the way, does anybody know where we're storing this stuff?
Proofs.
Thanks. That's right. That's a good idea. So we could have an entity store. Okay, so that's a different idea, which is a built-in entity store of these things. Well, I see. Or the other possibility is a resource object that is an entity store. Is that what you're effectively suggesting, Jose?
I'm not sure, but having entities behind this could be very flexible.
Yeah, I agree. All right, we need to go to a different meeting. Let's see. If Jonathan, if you can just, I mean, wherever your raw data is, just put it in a notebook and send it out to us. Okay, the raw data on these axiom systems, so that we can see what exists. And then I think, putting that data into an entity store, whether it is whatever is happening to it, that will be a good thing to do to it.
Okay. And
then what will happen is that the entity, Robinson arithmetic or something, if you feed that to find equational proof, see that the trouble is you need the operators, right? You need to know what the operators are to write down theorems. You can't write the theorems without knowing the operators.
But we can have defaults.
Yeah. And if the whole entity is parameterized by the set of operators, then in addition to the axioms having the operators in them, things like the notable theorems will also have the user-defined operators in them and stuff like that. I just think it's nicest if we allow the whole axiom system entity to be parameterized by the operators.
Yeah, but then it can't be a single entity because it's got to be a parameterized and it's got to be a function.
Right.
I see. So what you're saying is, so it would be axiom system, and then effectively, I mean, so one other model would be axiom system here of Robinson arithmetic. Whoops, Robinson arithmetic, and then we would have to say association, plus goes to F or something, times goes to G.
Right.
What you have in mind?
Yep.
With a default.
Mm-hmm.
That doesn't look very entity-like, does it? I think we should talk to Michael about this and see what he has to say.
There might be an entity instance or some variant that helps here.
That's a good idea. Yeah, entity instance is an interesting idea. All right. Can you ask Michael about that, Jose?
Yes, I can. Sure.
Okay. All right. I think it's time to go to the next meeting. All right. So thanks, Jonathan. Talk to you soon. Okay.
Talk to you soon.
Bye. Bye.
Bye.